Most trucks don't die. They're neglected. And that's not an opinion. That's something you see when you've stood under hundreds of them on a lift. I've watched a 300,000-mile Ford F-150 idle smoother than a 90,000-mile one parked right beside it. I've seen high-mileage Ford Super Duty work trucks that towed daily, idled for hours, hauled real weight, crossed 400,000 miles on their original engines. And I've also seen similar trucks from the same generation need full engine or transmission rebuild before 120,000 miles. Same manufacturer, same drivetrain architecture, completely different outcomes. The difference isn't luck. It isn't "you got a good one." And it definitely isn't random. It's discipline. It's understanding how modern engines actually fail. Because engines and transmissions almost never fail in one dramatic moment. They fail slowly, through heat cycles, through oil degradation, through microscopic metal wear that compounds over time, through neglected coolant, through transmission fluid that was never changed because someone believed lifetime meant forever. A 300,000-mile truck isn't built in one day. It's built every 5,000 miles. It's built every time you service it before something breaks instead of after. Today, I'm walking you through 12 proven steps. Not theory, not hype. The exact habits that consistently separate short-lived trucks from long-term survivors. Whether you're driving a naturally aspirated 5.0 Coyote, a twin-turbo 3.5 EcoBoost, a 6.2L gas V8, or a 6.7L Power-Stroke diesel, the longevity formula doesn't change. Let's start with the single biggest factor in engine survival. Step 1. Oil changes every 5,000 miles, not 10,000. Modern Ford engines operate under high thermal stress. Turbocharged EcoBoost engines in particular generate extreme localized heat. Turbochargers spin at over 150,000 RPM. The shaft bearings rely on a thin pressurized film of oil. When that oil oxidizes, thickens, or breaks down, lubrication efficiency drops dramatically. Oil degradation doesn't just mean dirty oil. It means viscosity shear. It means additive depletion. It means carbon particles circulating through precision components. Sludge begins forming in hot areas. Turbo fees lines, cam phaser passages, variable valve timing solenoids. Once those small oil passages restrict flow, you get delayed timing response. Then you get startup rattle. Then you get long-term wear. Factory oil intervals often assume ideal driving conditions. Long highway miles, minimal idling, no towing. Real life includes short trips, cold starts, heavy throttle, stop-and-go traffic, heat, dust, and load. If you want 300,000 miles, 5,000 miles is your ceiling. If you tow frequently, idle for work, or drive in extreme heat, shorten it to 3,000 to 4,000 miles. Use full synthetic oil in the correct viscosity specified for your engine. Use a quality filter with proper anti-drain back valve performance. The math is simple. An extra few oil changes per year is dramatically cheaper than cam phasers, turbochargers, or a long block replacement. Oil is not an expense. It's a longevity investment. Step 2. Timing chain and cam phaser awareness. Timing systems fail predictably, not randomly. On engines like the 3.5L EcoBoost and older 5.4-liter Triton V8, hydraulic tensioners depend entirely on clean, pressurized oil. Dirty oil accelerates chain wear. Worn chains stretch microscopically at first. That stretch alters camshaft timing. Cam timing deviation triggers compensatory adjustments from phasers. Over time, startup rattle becomes noticeable. That cold start rattle is an early warning, not background noise. If ignored, chain slack increases. Timing correlation codes begin appearing. P0016, P0017. Left unaddressed, extreme deviation can cause internal interference. Early intervention is far less expensive than catastrophic repair. Replacing phasers and timing components proactively costs significantly less than rebuilding a damaged valve train. Clean oil dramatically slows this process. Listening for new startup noises can save thousands. Step 3. Eliminate the lifetime fluid myth. No fluid is lifetime. All fluids degrade. Automatic transmission fluid experiences heat cycling, friction material contamination, and viscosity breakdown. As fluid shears, its ability to maintain hydraulic pressure weakens. That affects clutch engagement quality and torque converter performance. Consistent drain and refill service every 30 to 50,000 miles dramatically improves longevity. Avoid aggressive flushes on severely neglected units, but establish maintenance early and stay consistent. Differentials operate under extreme load, especially in towing applications. Gear oil breaks down and accumulates metal particulates. Service around 50,000 miles. Transmission cases depend on clean fluid for chain lubrication and clutch pack operation. Service around 50,000 miles. Brake fluid absorbs moisture over time. Moisture lowers boiling points and promotes internal corrosion. Replace it every 2 to 3 years. Fluid degradation equals heat. Heat equals wear. Wear compounds. Fresh fluids stabilize temperatures and reduce friction across the entire drivetrain. Step 4. Cooling system integrity. Thermal management is critical to engine longevity. Aluminum cylinder heads are highly sensitive to overheating. Even minor overheating events can compromise head gasket sealing surfaces. Coolant does more than prevent freezing. It prevents corrosion, stabilizes operating temperature, and lubricates water pump seals. Replace coolant within recommended intervals using manufacturer-approved specifications. Mixing incompatible cooling chemistries can cause precipitation and deposit formation inside passages. Watch for unexplained coolant loss. Inspect oil condition regularly. Milky oil indicates contamination and immediate action is required. Stable operating temperature preserves head integrity, bearing clearances, and long-term reliability. Step 5. Ignition system maintenance. Spark plugs influence combustion efficiency directly. As electrodes wear, spark intensity decreases. Incomplete combustion leads to misfires. Misfires introduce raw fuel into the exhaust system, elevating catalytic converter temperatures and stressing oxygen sensors. Coils also experience increased demand when plugs are worn. Replace plugs at proper intervals using correct torque specifications to protect aluminum threads. Ignition maintenance is inexpensive compared to exhaust system repairs. Efficient combustion equals reduced thermal stress and smoother operation. Step 6. Early diagnosis over late reaction. Mechanical systems rarely fail without warning. Unusual noises, vibration changes, hesitation under load, these are diagnostic signals. Waiting for a warning light is reactive. Investigating new symptoms immediately is proactive. Use a basic OBD2 scanner to monitor pending codes. Many faults register before a check engine light illuminates. Address minor issues early. A small oil leak becomes a gasket job. Ignore it long enough and it becomes contamination, overheating, and secondary damage. Long-term durability favors attentive owners. Step 7. Quality parts only. Labor is expensive. Repeating labor is worse. When replacing timing components, sensors, gaskets, or cooling system parts, use OEM or high-quality equivalent components. Manufacturers often release updated revisions addressing early design weaknesses. Cheap components may function temporarily but lack long-term durability. Doing the repair once with quality parts prevents duplication of labor costs. Step 8. Transmission temperature management. Heat is the primary enemy of automatic transmissions. Fluid oxidation accelerates rapidly as temperatures rise beyond optimal operating range. If your truck provides transmission temperature data, monitor it under load. Consistent high temperatures warrant shorter service intervals or additional cooling capacity. Thermal control extends clutch life, valve body performance, and torque converter integrity. Step 9. Rust prevention. Longevity isn't just about engines, it's about structure. In corrosive climates, salt accelerates oxidation of frames, brake lines, and suspension mounts. Regular undercarriage cleaning during winter months reduces salt retention. Corrosion protection treatments significantly slow structural degradation. An engine can survive 300,000 miles. A rotted frame cannot. Protect the structure and you preserve the investment. Step 10. Electrical system stability. Modern trucks rely on voltage stability. Control modules, fuel systems, transmission solenoids all depend on clean electrical supply. Weak batteries cause erratic module behavior and false fault codes. Replace aging batteries before failure. Maintain clean, corrosion-free terminals. Stable voltage prevents cascading electronic issues. Step 11. Alignment and rolling resistance. Improper alignment increases rolling resistance and places uneven load on drivetrain components. Wheel bearings, steering racks, and suspension joints experience accelerated wear under constant misalignment. Rotate tires consistently and perform alignment checks when uneven wear appears. Reducing mechanical strain across the chassis contributes to long-term reliability. Step 12. Mechanical sympathy. Driving style matters. High RPM operation before oil reaches operating temperature increases internal friction. Aggressive throttle inputs create shock loads through drivetrain components. Allow proper warm-up before heavy acceleration. Apply throttle progressively. Avoid unnecessary stress. Mechanical sympathy costs nothing and extends component life significantly. 300,000 miles isn't a miracle. It's a system. Clean oil, controlled heat, fresh fluids, early diagnosis, quality components, respectful operation. Vehicles don't usually fail from one catastrophic event. They fail from thousands of small neglects stacking up over time. Reverse that pattern and longevity becomes predictable. If this guide helped you and you're serious about building a high-mileage truck the right way, subscribe to the channel. I post long-form mechanical breakdowns designed to save you money and extend the life of your vehicle. Turn on notifications so you don't miss upcoming deep dives, and drop your current mileage in the comments. I want to know who's pushing toward 300,000 and beyond. Maintain with intention. Drive with discipline, and your Ford might outlast everything around it.